So at this point, we've really talked about all the different types of completion stage methods, the ones that trigger when one stage finishes, ones that trigger when both of previous stages trigger, ones that are going to trigger when either of previous stages trigger. So now let's go ahead and see how these things all get applied in an example. And this will be the EX8 project we've been talking about so far. So we're going to show a particular example from the EX8 project in my Java 8 folder in Live Lessons GitHub repository. And this is called Test Fraction Multiplications 1. As you might expect, there's a Test Fraction Multiplications 2 method that does other things. We're not going to look at that right now. But this is kind of a fun example. And you're also going to see how this example combines Java sequential streams along with completable futures in a way very similar to what you'll need to do for assignment 4. So you should get a lot of insights from seeing this use case. So what we're going to do is we're going to use the generate factory method on a stream. We haven't talked a lot about generate. Generate basically will take some kind of function, I think, and it'll just call it forever, continually until it's done. Now, in this case, we're going to limit it to a certain number. But what we're going to do is we're going to generate random, unreduced big fractions. And we're going to generate S max fractions of them. Let's say that's set to 100 or 10 or whatever. So that's what this will do. Here's what make big fraction does. It's a fun little factory method that will create a ridiculously large and random big fraction. And here's what we're going to do. We're going to pass in a random number generator and a Boolean flag to indicate whether to reduce it here or let it be reduced later. In this case, we're going to reduce it later because we pass in false. And we then make a humongous numerator, which is randomly distributed over the range 0 to 2 to the 150th power minus 1. So that's a pretty big number. We're then going to create a denominator which takes that, which makes a random number between 1 and 10, so it's a lot smaller. And that's what is going to be our big fraction. And then we make a big fraction with the numerator and denominator and the reduced flag, which is set to false. So you can imagine why this program takes a while to run, because these are very, very, very large big fractions. Because it's going to take a long time to run, we then want to do all the reduction and multiplication of these big fractions asynchronously. So we're going to use the map method, which is the aggregate operation, the intermediate operation for streams, and we're going to pass in essentially I think it's a supplier, it's a function that will reduce, it's a function that reduces and multiplies the big fractions that came through that are gigantic and random and unreduced. Here is what test fraction multiplications 1's reduce and multiply fraction function looks like. You can see it takes a big fraction, which is this gigantic random big fraction, it's unreduced, and it returns a completable future to a big fraction that, when done, when triggered, when complete, will give the results of reducing and multiplying that big fraction. So that's what that does. It's essentially a function, it's a lambda function that will asynchronously reduce and multiply big fractions. Here's how it works. We use supply async to take the unreduced fraction and reduce it. So that'll run off in the background. And then we use thenCompose to asynchronously multiply that reduced big fraction. So that will asynchronously multiply things. And you can see here that we use thenCompose, similar to flat map, to make sure that we get a completable future as opposed to a completable future to a completable future. Notice, by the way, we also could have done, and probably should have done, a replacement of thenCompose supply async with thenApply async. I think you would agree that's a little bit cleaner. It's easier to see. This is a little bit complicated to look at visually. You have to kind of know the idiom to know what it's doing. But this is a cleaner way to do things. So we don't have to call supply async again. All right, so what happens here when we do this, the input to map was a stream of random, gigantic, unreduced big fractions. And the output of map will be a stream of completable futures to big fractions. That will be running asynchronously in the background, doing the reduction and multiplication. What we do next is very important to understand, especially for assignment 4. We're going to collect that stream of asynchronously running completable futures to big fractions into a single completable future that, when all the things running in the background complete, will itself complete. This is a really cool idiom, one of the nice ways of combining Java sequential streams with completable futures. So I absolutely love this thing. So we'll talk about that in part 2 of this lesson. So that was a quick overview of the flow, and now we're going to talk about the collector portion, the last part of this example.